Hi everyone, this is Hossein from EJ Academy. Amir is here with me today. Hi Amir,
Hello,
how are you doing today?
I'm good, thank you.
All right. So Amir, I have a problem for you today. It's about derivative in calculus.
Yeah.
Uh, so this time, I need your help solving this problem. This is about application of derivative.
hmm
And so I have a problem. It's about rate of change. So let me read that problem for you first.
Okay, thanks.
So we have an airplane. There is an airplane travels at a speed of 800 miles per hour while maintaining its altitude at 30,000 feet above ground. If a standing still observer on the ground sees the plane flying toward her at an angle of elevation of pi/6 radians, what is the rate of change of the angle of elevation at this moment? So
Yes.
floor is yours. Please go ahead and show how you can solve this problem.
Okay, sure. Let me start. Okay, we have the airplane, the maintaining, which maintains, the altitude. So the altitude is constant at this value. The observer is also fixed. It doesn't move. But the plane moves, in the horizontal plane.
Right. Maybe if you draw a diagram showing this,
Yes,
it's help to better visualize what's
um,
going on.
if this line is ground surface and if this point here is observer and
It's not moving.
this
It's
point, yes, yeah, and this point is plane. Um, the observer is looking at plane, and the plane has an altitude of 3,000.
30,000.
30,000, yes. So it is 30,000 feet. And the plane is moving in this direction,
Right. It's going
maintaining the
horizontally.
altitude. Yeah.
Right.
So we want to have the rate of change of the angle of elevation. The angle of elevation is this angle. I call it theta. So as the plane moves, for example, here, this is going the new theta. When the plane is here, this is going to theta. So this value is changing as the plane moves in this direction.
It's increasing.
Yes, theta is increasing. And also the velocity of airplane here is 800 miles per hour. So let me define this as h, and let me define this length as x.
Okay.
So h is constant, but x is decreasing actually. So for example,
Because
when
the
the
plane
plane is
moving toward.
here, yeah, x is this much. So since the x is decreasing, I'm going to conclude that this velocity is negative because velocity is x over time. So when x is negative, the velocity is also negative.
Correct. Yep.
So that's that's about the velocity. But the question
Mhm.
is, what is the rate of change of theta at this moment when
Mhm.
actually theta is pi over 6? So let me write
Okay.
it
Actually,
down.
let me. I think you need to make some modification. The equation you wrote for V, so V is change of x to change of t, so it's probably delta x or dx over dt
Yes, yeah,
rather
that's
than x.
that's
You're
the
talking about
average.
change, right?
Yes, yeah, that's the average of velocity. So we want to have this one
Mhm.
next to that.
Mhm. Mhm.
So it's like average of velocity. Okay, so the question is about d theta over dt.
Mhm. That's
Uh,
the rate of change of the angle of elevation.
correct. So let me just establish the relationship between theta and other parameters. So we know
Okay.
that tangent of theta, because
Mhm.
uh, this is a right angle triangle.
Mhm.
Uh,
Mhm.
so tangent of theta is h over x.
Front to
In
side.
other words, yes, yeah. This to this, yeah.
Mhm.
So, oops, let me change the color. Theta is arctangent of h over x. And we know that h is constant, but x is changing.
Right.
So, and the question is d theta over dt. So
Correct.
based on this, I'm going to take the derivative of this function, d theta over dt is equal to, okay,
Mhm.
here we see that theta is in terms of x, but we know that x itself is a function of time.
Mhm.
So I'm going to use the chain rule here.
Okay.
So it's d theta over dx, which we have in
Mhm.
this equation. And again, since x is a function of time, it's dx over dt. So
Okay.
in other words, I'm using a chain rule here.
That's correct. Yeah, this is an application of
Yeah,
chain rule.
that's correct.
Mhm.
So I need to, okay, this one, let me change the color here. This one is velocity.
Mhm.
Uh,
Yeah, change of position relative to change of time.
correct. Which is negative 800 miles per hour.
Correct.
But we need to have actually this term here.
Okay.
So I need to take a derivative of,
Yeah, you already know the relationship between theta. Yeah, up there, you have the
yes,
relationship between theta and x, then it's easy
correct.
to find.
That's
Mhm.
correct. So d theta over dx is equal to, we already know the derivative of arctangent of um, an angle. So it's going to be
Mhm.
derivative of h over x here in terms of x over
Mhm.
1 plus h over x squared. And
Right.
that is equal to
The one in the numerator can
Yeah, h is constant.
It's easy, right?
Yeah, so
It's a quotient rule.
it's a quotient rule. So the derivative of the numerator times denominator. So the derivative of numerator h is 0 times denominator is 0 minus derivative of the denominator x in terms of x, which is 1 times h over
Right.
x squared
X squared. Correct.
plus h over x squared. So I'm going to simplify the relation. So it's going to be x squared plus h squared. So I cancel these out. And then, therefore, d theta over dx is equal to negative h over x squared plus h squared.
Correct.
Okay, so far we have this term which is known. We obtained the derivative of this of theta, which is this one. In here, this is known, but we have to determine x, and it is given, you know, not directly but implicitly by in the problem statement, since it says that you know, at the angle of pi over 6. So at this angle, we can obtain the value for x, because it's simply, you know, h over x for the tangent of theta. So given that, I'm going to use okay, tangent of theta, which is pi over 6, as given in the problem statement here, is equal to h, which is okay, 30,000 feet.
You need to be careful here. They are like in different units.
Correct. I'm gonna actually divide it by 5,280. I think that's the value.
Yeah, one mile is 502,080 feet.
Yes, 1 mile is so that's it. I changed the unit to miles. So it's going to be like that to be more accurate.
Then it's consistent with the unit of the velocity, which is mile per hour.
Yes.
Yeah.
And then yeah, that's the reason we want to change it to mile, because the velocity is miles per hour.
You can do otherwise.
Yes, we can play with actually feet instead
change
of
velocity to mile per hour.
Yes,
to foot per hour.
So x is equal to
do you want me to calculate that for you? You have a calculator?
Yeah, I have
Let
it
me
here.
do that for you.
Okay, yeah, I appreciate it. Sure.
Okay, so 30,000 divided by 5280, and then that divided by tangent pi over 6 is 30 degree, I believe. So is 9.84.
Yes. Oops, I changed this. 9.84. It's going to be miles.
Right, we changed the unit to mile.
So therefore, we have all the ingredients to obtain the rate of the rate of the change of the theta. So it's let me name this number 1, equation number 1. equation number 2 and number 3 value here. So based on these, d theta over dt. Sometimes in engineering context, we call it theta dot, but
right.
Yeah.
Yeah, the dot notation, or is that called dot notation?
Dot notation.
That is when you take the derivative with respect to time. Usually.
Correct. So it's going to be this one, because we have it here. Negative h, which is perhaps it's good to have this value, Hossein.
Okay, let me give it to you. 30,000 divided by 5280. It's 5.68.
Okay, thank you.
We have 5.68 on the numerator. You're using number 2, right?
Yes.
5.68 divided by x squared 9.84.
Yeah, in here. Correct.
9.84 squared plus 5.68 squared, huh? Okay.
Times the velocity here.
Right. Velocity was negative 800, huh?
Correct.
Yeah. Negative 800. And the unit for all of them are like mile or mile per hour.
Yes, everything is
consistent.
mile. Yeah. So
and
yeah,
times
it is
800. So I can give you the whole the result, the final result.
Sure,
is negative 35.2.
The whole equation
thing.
So
right.
It's okay. Positive.
You wanna part by part?
No, that's okay. The final answer is, you said?
Yeah, I'm sorry, positive. 35.2.
Okay, I'm gonna check the units. It's very important always to check the units. So this is miles per hour.
Right.
This is miles. In the numerator, in the denominator is miles squared.
The square.
So we cancel out the miles.
So we have 2 miles on the numerator.
Yeah.
Multiplied, and the mile squared and the denominator, they cancel.
So the answer, the final unit or dimension is per hour, which is radians per hour.
Radian per hour.
Yeah. So that's the
35 positive, 35.2 radian per hour.
That's correct.
So the answer is positive. So that is one check, which is correct, because you know, as the airplane moves toward the observer, the angle is going to increase.
That's correct. Yeah,
right.
It should be positive because, it's, as we mentioned, it's going to increase.
Okay. Yeah. All right. Thank you, Amir. I appreciate it.
Sure.
So that is for today. And I hope the viewers enjoy this problem, and I appreciate if you consider subscribing to our channel. Also hit the notification bell for future videos. Till next video, bye everyone.
Bye. Thank you.